Hi folks, welcome to Unit 7, Lesson 1. So we're going to start by reviewing the steps to the question you should have already completed. So they asked you to find the x-intercepts of this quadratic function, but if you take a look, clearly factoring is not going to work here. So your only other alternative is to do it by completing the square. All right, let's just recall the steps here. So when completing the square, step number 1 is always to factor out whatever the a value is in front of the x squared, regardless of what it is. All right, out of the first two terms. Then with what's left in the bracket, that's what you're going to use to actually complete the square. So again, this middle term must be written as 2 times an expression, and then you add and subtract the square of that expression, in this case here, 5 over 2. Then it's the first 3 terms in the bracket that produce the perfect square, and then of course you still have this subtraction of that square, so minus 25 over 4. Then you distribute and eventually get it into vertex form. Then once you get it into vertex form, you can then replace y by 0 since you're looking for the x-intercepts, and then you can solve by opposite operations. And in this case here, we saw that we got 2 answers. So this works, but it's a very long process just to find x-intercepts. So this is where we're at now. Finding x-intercepts for quadratic functions is an extremely important task, something we're doing all the time. And the method we have that always works, while long, is always the exact same steps every time. So while bad news is that it's a long process, the good news is that maybe we can find a formula to avoid having to do all these steps every time. The reason why we might be able to find the formula is because this procedure is the same every single time. So instead of starting with a specific example, what we're going to do is we're going to start with the most general quadratic function in standard form, ax squared plus bx plus c, and see if we can follow these exact steps all the way through and see if we can actually find a formula for these x-intercepts so we can just get them using that formula instead of having to go through the steps. So that's our goal here. All right, so let's start with our function here, and I'm going to be constantly referring to this example here because I'm going to follow the exact same steps, because the steps I followed here are exactly the steps we would have followed in every other example where we were doing the same thing. All right, so here, step number 1 is to factor out the coefficient of x squared regardless of what it is. And in this case here, the coefficient is a. So I'm going to factor out the a from the first 2 terms. So here, nice and easy, I'm just going to be left with x squared. The second term, okay, now remember, when we're factoring out a number, what we're doing is we're dividing it out, okay? So what we're going to be left with here is plus b over a times x. And then the plus c, okay, like we did before, we're going to leave that till the end. All right, now remember, anytime you do some factoring, you can always check that you did it correctly by going backwards. And if I redistribute a times x squared, ax squared, and then a times b over a, well, the a's are just going to reduce, and I'm just going to be left with bx. So this is correct. All right, so now the goal is to complete the square inside the bracket. So I don't worry about the a right now. So I have x squared, and I have to write this as 2 times some expression times x. Okay, now again, the way in which we can do that is by dividing by 2. But let's recall that dividing by 2 is the same as multiplying by a half. So b over a, okay, divided by 2 is the same as b over a times 1/2, which of course is just equal to b over 2a. Okay, so this expression inside the bracket is just b over 2a. Once I have that expression, I know the next step in completing the square is adding and subtracting the square of that expression. So I'm going to be adding here a b over 2a squared and subtracting a b over 2a squared. All right, so I'm following just the exact same steps as I would have before, except with these numbers a, b, and c left as unknowns. Okay, so let's move on. We know that it's the first 3 terms, okay, as we had here, it's the first 3 terms which produce the perfect square. So here, this is just going to be x plus b over 2a squared. Okay, and again, if you want to check it going backwards, square the first, square the last, twice the product of first and last. All right, But of course, we're still left with this minus b over 2a squared. Okay, and let's expand this here. So since I'm squaring a quotient, that's the same as squaring both the numerator and the denominator. So this is just going to be b squared over, and be careful here, 2a is being squared. So when I do that, it's 4a squared. All right, and then plus c. Okay, so what was the next step? Once we completed the square inside the bracket, we now redistributed the a value back to everything in the bracket. So I'm going to do the exact same thing here. I'm going to distribute the a to the first term. So ax plus b over 2a squared, okay, minus. Now when I multiply this to the second term, I realize, I've got an a in the numerator and an a squared in the denominator. So the a in the numerator is going to cancel out with one of the a's in the denominator. So I'm just going to be left with b squared over 4a, and then plus c. Okay, so what we've done now is we've essentially completed the square. Okay, except instead of having specific numbers in all of these positions, we have these unknowns. Okay, so now that I've completed the square, the next step is to replace y by 0 and solve for x using opposite operations. All right, so while I have the 0 here, I'm actually going to move stuff to the other side, but I'm just going to write the equation flipped around. Okay, so how do we solve by opposite operations? Well, first we start with the additions and subtractions, and then we'll move from there. All right, so I'll keep this a times x plus b over 2a squared. Okay, and I'm going to bring these two expressions to the other side of the equation. So this minus b squared over 4a is going to become positive b squared over 4a. Okay, and this plus c, when I bring it to the other side of the equation, is going to become minus c. All right, now before I divide the a, I'm going to simplify this expression here. Okay, I'm going to subtract this using subtraction of fractions. So I'm going to do this here on the side. So remember, in order to be able to subtract fractions, they need to have the same denominator. Okay, so I'm going to take that b squared over 4a, okay, and I need to have a denominator of 4a in the second expression. Okay, but if I multiply, because remember this is like c over 1, if I multiply the denominator by 4a, I have to multiply the numerator by 4a. Okay, so how am I going to add these together? Well, now I can do that because I have a common denominator. So the numerator is going to be b squared minus, and I'll just rearrange this. This is multiplication, so I can do it in any order. I'll write it as 4ac all over 4a. All right, so now we can go to the next step, which is to divide both sides by a. So now that first I took care of the addition subtractions, now I'm going to take care of the multiplication. Okay, so here I'm left with x plus b over 2a squared. And here I'm going to divide numerator and denominator by a. Remember, dividing by a is the same as multiplying by 1 over a. So this is like b squared minus 4ac over 4a. Dividing by a is like multiplying by 1 over a. So the only thing that changes here is when I multiply these two fractions, I'm going to end up with an a squared in the denominator. Okay, so I have b squared minus 4ac all over 4a squared. Okay, next step now is to take care of the exponent. And of course, the way I can take care of the exponent too is by doing its opposite operation, which is square root. Okay, so x plus b over 2a. But we have to be careful here because when we take the square root of both sides of the equation, we have to consider that there's both a positive and a negative square root. All right. So it's at this step here that we have to use a property that you're really not going to learn officially till next year. Okay? But you'll just have to trust me on it. So in the same way that if you have a over b squared, that's the same thing as a squared over b squared, okay? You have a similar property for square roots. If I have the square root of a over b, that's the same thing as the square root of a over the square root of b, okay? So what we're going to be able to do here is write this as plus or minus the square root of b squared minus 4ac in the numerator over the square root of 4a squared. But before I write the square root of 4a squared, I want you to notice these are both perfect squares. I'm going to write 4a squared as 2a all squared. And look what we have. We have the square root of a square. They cancel each other out. They're opposite operations. Okay, so finally, in this last step, okay, I'm going to bring this positive b over 2a. The plus b over 2a is going to become a subtraction. Okay, and I'm going to choose to write it in this form here, just because it's the usual form we use. Okay, so we have this plus b over 2a becomes negative b over 2a, plus or minus square root of b squared minus 4ac all over. And what did we just find? The square root of 4a squared was just equal to 2a. And look how nice that is, because we've got two fractions with a common factor. Sorry, a common denominator. And since it's just addition and subtraction, I can bring these two things together and rewrite this as negative b plus or minus square root of b squared minus 4ac all over 2a. And this, folks, is one of the most famous and important formulas in mathematics. It's what we call the quadratic formula. All right, so let's not mistake it for a quadratic function. So a quadratic function is a function whose graph is represented by a parabola. Okay, this is the formula that helps you get the x-intercepts of a quadratic function. So if I replace y by 0 and I'm having to solve this equation equal to 0, in other words, the x-intercepts, this formula gives me those answers automatically. Okay, so you might think to yourself, wow, that was a lot of work we did. This was so much more complicated than what we had to do when there were actual numbers. But this is what you have to realize, is that now that we've proven that this formula is correct, you never have to go through that. You never have to go through that whole process again if all you're looking for are the x-intercepts. And just to confirm that this indeed does work, all right, I'm going to apply this formula to the example in number 1. Okay, so if we take the example from number 1, we were looking for the x-intercepts of that function. So I have y equals negative 3x squared, minus 15x plus 1. And I want to find the x-intercepts. In other words, I make y equal to 0. I can do that by just applying this formula, okay? Because I generated this formula by doing it with the most general quadratic you can get. Okay, so let's apply the formula here. So x is going to be equal to negative b. So negative b, now b here is negative 15, a is negative 3, and c is 1. So negative 15 plus or minus. Okay, so all I'm doing here is I'm just following this formula. So b squared, so negative 15 squared, minus 4 times a. A is just negative 3 times c, which is 1. Okay, and all of this over 2 times a, so 2 times negative 3. And so if we simplify this a little, eventually you won't be simplifying. We're just going to put everything into your calculator, but let's simplify it a little. So negative 15 is positive 15, plus or minus. Okay, so this, well, let's just put it in our calculator, but we could probably do this in our head here pretty quickly, because negative 15 squared is just 225, and this is going to end up being plus 12. Okay, so I think that's going to be 237. So let's just put in our calculator just to be sure. So negative 15 squared minus 4 times negative 3 times 1, okay, is 237. So square root of 237, and then all over negative 6. Okay, and what we're going to do now is we're going to show that these answers are exactly the ones we got up here. So remember, the answers were 0.0659. Actually, I think it was 658. Okay, and here negative 5.0658. All right, so let's check that here. All right, so do this carefully on my calculator. So I've got 15 plus the square root of 237. Okay, and then I'm going to divide that by negative 6. And lo and behold, that's exactly one of the answers we got before. So negative 5.0658. And let's put in the other one. We've got 15 now minus square root of 237 equals, and let's divide that by negative 6, and that's exactly what we had before, 0.0658. Okay, look how much work it took us to determine those answers here as compared to the amount of work it took to find those exact same answers. Okay, so hopefully you can appreciate that while we had to do a little suffering going through this problem, keeping unknowns in the equation, once you have the formula, solving for these x-intercepts when you can't factor is going to be very fast. Okay, so the question is, do you need to memorize this formula? Not only do you need to memorize this formula, you need to know it September 1st next year. You need to know it September 1st in grade 12, and hopefully if I see you in the street 15 years from now, you should be able to give me that formula. So what's the quadratic formula? X equals negative b plus or minus square root b squared minus 4ac all over 2a. Start practicing it now. All right? So use this example to do the ones on the other side of the sheet, and we'll take those up in a little bit.